Hello students, welcome to mathematics class. Students, this is part 4 of the chapter direct and inverse proportion. We are going to learn in this part 4 inverse proportion. Coming to the inverse proportion, two quantities may change in such a manner that if one quantity increases, the other quantity decreases, or increment in one quantity causes decrement in another quantity, and vice versa, may be called as that they are inversely proportional. I will give you example. As the number of workers increases, time taken to finish the job decreases. Similarly, if we increase the speed of the vehicle, the time taken to cover a given distance decreases. These are simple examples, but every time increment in one quantity causing decrement in another quantity may not be called inverse proportion. To understand it thoroughly, let us look into the following table. Here in the situation, Jahida can go to her school in 4 different ways. 1. She can walk. 2nd. She can run. 3rd. She can pedal a cycle, or she can go by a car. Suppose, let us study the table. Suppose if she goes at the speed of 3 km per hour walking, she will reach her school in 30 minutes. Suppose if she runs at the speed of 6 km per hour, then she will reach in 15 minutes. Whereas if she pedals a cycle at an average speed of 9 km per hour, then she will reach her destination, that is school, in 10 minutes. At last, if she goes by car at an average speed of 45 km per hour, then she will reach the school within 2 minutes, just 2 minutes enough. Now, if you observe this, what do you say? Observe that the speed of the vehicle as increases, or the mode of that she going gives more the speed. As the speed increases, time taken to cover the same distance is decreasing. Here is an example for inverse proportion, but let me give you, there are conditions here. Those conditions first we shall discuss. If the speed doubles from 3 to 6, then the time taken to reach is becoming half. When speed of going triples, while pedaling up it is tripling, it is getting tripled, then the time taken to reach the destination is becoming 1/3. Suppose if the speed increases for the 15 times, 15 folds, then the time, if the speed increases by 15 times, then the time taken to reach the destination is decreased by 1/15th times, or 1/15, 1/15th we say, 1/15th times. This is what you could observe. Here, as Jahida doubles her speed by running, time reduces to half. As she increases her speed to 3 times by cycling, time decreases to 1/3. Similarly, as she increases her speed to 15 times, time decreases to 1/15th. These are all the further observations, along with one quantity increasing causing decrement in another quantity. Here you could say, in other words, the ratio by which time decreases is inverse of the ratio by which the corresponding speed increases. What does this mean? The sentence. Let me explain. The ratio by which the time decreases. Here, the time decreasing by half, this half is inverse of double. Double means 2 times. 1/3, it is inverse of 3 times. 15th, 1/15, that is 1 by 15 is inverse of 15. You could see 2 is inverse of 1 by 2 or 1 by 2 inverse of 2. 1 by 3 is inverse of 3 or 3 is inverse of 1 by 3. 15 is inverse of 1 by 15 or 1 by 15 is inverse of 15. If you know one important property called multiplicative inverse. Multiplicative inverse of a number is its reciprocal. Thus, half is inverse of 2 and vice versa. We learned this in one of the number system properties, multiplicative inverse. From this word only the name of this inverse proportion has come. So, the ratio by which time decreases is inverse of the ratio by which the corresponding speed increases. Children, can we say that the speed and time change inversely and they are inversely proportional, right? Certainly we can say that speed and time change inversely. And here we shall learn one more example and understand this concept. A school wants to spend rupees 6,000 on mathematics textbooks. How many books could be bought at rupees 40 each? If each book is of rupees 40, with the fund available rupees 6,000, how many books that we can buy? Suppose if you want to calculate, divide 6,000 by 40 rupees, you will get 150, where it shows that you can buy exactly 150 books. If the price of a book increases or is more than rupees 40, definitely I cannot buy 150 books with the same fund available rupees 6,000. Here, with the constant of that fund available, we will buy less than 150 books. If that fund available is fixed as the cost of each book, if it is more than 40, then I will buy less than 150 books. Observe the following table. Here in this table, I have taken one column containing price of each book in rupees, another column corresponding number of books that can be bought out of 6,000 rupees as a fixed, having each book as the given price. If each book is 40, I will buy 150 books. If each book is 50 rupees, then I can buy only 120 books. If each book is 60 rupees, then I can buy 100 books. If each book is 75 rupees, then I can buy 80 books. If each book is 80 rupees, then I can buy 75 books. If each book is 100 rupees, then I can buy only 60 books. Here you could observe increment in the cost of each book causing the number of books that I can buy decreasing. The number of books that I can buy are getting decreased as the cost of each book is increasing. Here we can say both the quantities are inversely proportional. But what extra can we observe? What further can we observe? What do you observe more than that? As the price of books increases, the number of books that can be bought, keeping, very important here, keeping the fund constant, available fund as rupees 6,000 as constant, number of books purchased will decrease. What extra that we can observe is our next thing, ratio by which the price of books increases, ratio by which the price of books increases when going from 40 to 50, that is 4:5, and the ratio by which the corresponding number of books decrease from 150 to 120, that is 5:4. You could observe these two ratios are inversely proportional. 4/5 is inverse of 5/4. That is what I am going to bring. This means that the two ratios are inverse. The two ratios are inverse of each other. You know, 4/5 is inverse of 5/4. So, we are going to take the same checking whether this inverse proportion have the same this sort of relation. Coming to the, notice that the product of the corresponding values, of two quantities is constant, that is 40 when it is multiplied by 150 gives 6,000, even 50 when it is multiplied by 120 also gives 6,000. Here the product of 40 and 150 and 50 and 120 is remains constant. I will show you here. The product of 40 and 150 and 50 and 120 and 60 and 100, 75 and 80s and 80s and 75s and 100s and 60s remains constant. Here 40 into 150 gives 6,000 only, and 50 into 120 gives 6,000 only, 60 into 100 gives 6,000. So here the fund, keeping the fund constant, that rupees 6,000 is coming as constant. For example, if I take cost of each book as x1, x2, x3 and so on, and corresponding number of books purchased as y1, y2, y3 and so on, x1 into y1 is equals to x2 into y2. So the product of corresponding values is becoming constant. So this condition is very essential to say two quantities are inversely proportional, along with the increment in one quantity causing decrement in another quantity. That is, here if we represent the price of one book as a x and the number of books bought as y, then as x increases y decreases and vice versa. It is important to note that the product of xy remains constant. To call x and y as inversely proportional, the product of x and y should be constant. We say that x varies inversely with y and y varies inversely with x if the product of xy remains constant. Thus, two quantities, you note down this as a definition, two quantities x and y are said to vary inversely if there exists a relation of the type x into y equals to k between them, where k being a constant. So with this we will get, if y1 and y2 are the values of the y corresponding to the values of x1 and x2 of the x respectively, then x1 into y1 is equals to x2 into y2, that gives k, or in another words, this multiplicand can be brought here, x1 by x2 equals to y2 by y1. This is another important formula when you are solving problems from the inverse proportion. We say that x and y are inversely proportional with this condition. Hence, in this example, cost of a book and the number of books purchased in a fixed amount are inversely proportional. Similarly, speed of a vehicle and the time taken to cover a fixed distance changes inversely. Now the time to solve some questions. Here I am giving you, try these. Observe the following tables and find which pair of variables, here x and y, are in inverse proportion. So to check, I'll straight away take product of 50 and 5 is 250, product of 40 and 60 is 240, which is not equal. So therefore table 1 is not inversely proportional. Coming to the table 2, product of 160 gives 6000, 20 and 230 gives 6000, 320 gives again 6000, 415 gives 6000. Therefore second table is in inversely proportional. Coming to the third table, you could observe that product of 90 and 10 is 900. Here I am writing down below 900. 60 and 15 900. 45 and 20 product is 900. 30 and 25, here it is not 900. So 25 threes are 750, 20 30s are 600, 35 5s are 35 5s are is 5 5s are 25 2, 5 3s are 15, and it is 175. So third is also not in inversely proportion, though I could see in first 3 columns, but it is not same case as the rest of the things. You need to observe all the values. Their product should remain, corresponding values, product of corresponding value should remain constant. Okay, so coming to the another important point, when two quantities x and y are directly varying, then we write them as this way, symbol. This is called proportion symbol. Proportion, proportional to, we will read this as proportional to, and this is the symbol of proportional. So x is proportional to y, and when two quantities are inversely proportional, we write with the same symbol but 1 upon, this is 1 upon. So we say x is proportional to 1 by y, or x is inversely proportional to y. Okay, either you can read this as x is inversely proportional or x is proportional to 1 by y. Okay, 1 by y nothing but it is reciprocal of y. That gives inverse nature. Okay, so this is one more important in your class 9th. You will be learning two important laws in chemistry. One is Charles law, another is Boyle's law. There you will be using these symbols and learning very important properties of gases. So you need to have this knowledge for that. Coming to the example number 7. See, in example number 7, 6 pipes are required to fill a tank. 6 pipes are required to fill a tank in 1 hour 60 minutes. So, where the volume of a tank remains same, how long will it take if only 5 pipes of the same type are used? Now, here let the desired time to fill the tank be x minutes. Thus, we have the following table formed. Number of pipes 6 will fill in 80 minutes the tank. If the number of pipes is 5, then they fill in x minutes the same volume of the tank. Lesser the number of pipes, more the time will be required to fill the tank. So this is the case of inverse proportion. So in inverse proportion, product of 80 and 6 should be equals to 5 and x. So 80 into 6 equals to x into 5, and this multiplicand if I transpose there, it divides. So 80 into 6 by 5 equals to x. On simplification, it gives 96 as x value. That means it takes 96 minutes, or I can say 1 hour 36 minutes as the time taken by 5 pipes to fill the same tank. Now coming to the example number 8. In example number 8, there are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group? So 100 students with the same quantity of food provisions will be coming for 20 days, will be lost for 20 days, whereas 25 more students means 125 students, if they are there, then definitely it will come less than 20 days. Now let's go for the solution. Suppose the provisions last for y days when the number of students is 125, and we have the following table. For 100 members 20 days they will come. For 125 members less than 20, let that y number of days it will come for. And note that more the number of students, the sooner would the provisions exhaust. Therefore this case is of inverse proportion. You know, here when this is the case of inverse proportion, the product of 120 is equals to 125 and y, and if I send 125 which is multiplicand the other side, by transposing it divides. So 100 into 20 by 125 is the value of y. On simplification, y is 16. That means for 125 members the same food provisions will last in 16 days. So we will conclude like this. Now students, coming to the alternative method. Alternatively, this x1 into y1 is equals to x2 into y2 can also be written as x1 upon x2 is equals to y2 upon y1. Inverse, you know, 1 by 2 is inverse of 2 by 1. So that's how x1 by x2 is equals to y2 by y1. So in the table 100 members upon 125 members, and for 100 members it is last for 20 days, and for 125 members it may come for y days. So 100 into 20 by 125 gives y. Same on simplification, 16 will be the value of y. So x1 is to x2 is equals to y2 is to y1. We have the same thing written in proportion. Equality of two ratios is called proportion. You have already learnt in comparing quantities chapter. So x1 is to x2 equals to y2 is to y1. 100 is to 125 equals to y is to 20. Product of means equals to the product of extremes. 100 into 20 equals to 125 into y. Y equals to 100 into 20 by 125, which gives 16. Now here I am giving you homework. Homework will be example number 9. Note down this is a homework. Example number 9. Solve on your own. So with this I will wind up this session. Take care of yourself. Jai Hind. Thank you.